this is question 4 on an AS Pure Mathematics paper for the edXcel series aimed at Year 12 students, but also Year 13s and full A-level students. So sketch the curve with the equation y is equal to k over x, where x doesn't equal 0, where k is a positive constant, so k is bigger than 0. Now this is what I call a reciprocal graph. So we've got y equals 1 over x, for example, x to the minus 1, or x to the minus, 2 over x, 3 over x, etc. So what does that actually look like? Well, it's going to look something like this, It's going to look something like this, It's going to look like that, it's going to look like that, And these two endpoints, it's not meant just they get closer and closer to the axes, both x and y, but they never actually touch it, so they're what we call asymptotes. That just means that it gets closer and closer to the x and y axes from the positive quadrant and the negative quadrant. We don't actually touch it, and that's because we can't solve the equations. K over x equals 0, or 0 equals k over x. So you can't actually solve k over x equaling 0. So y can't equal 0, and of course obviously x can't equal 0 because I can't obviously divide by 0. So these two here don't obviously exist. That doesn't work. This doesn't work here because if I times through by x, we get that k is equal to 0 times x, so k has to be 0, which is not true because k is a positive constant, bigger than 0. I mean, k can be 0, it just means that you get y to be 0 as well, because 0 over x, means 0, but there has no real value. It makes sense, it has no real value. Y equals 0, it's just the x-axis, if that makes sense. But that is what it looks like, and it's called the reciprocal graph. And you might hear some A-level teachers or A-level maths teachers or tutors say the word asymptote. I might have actually spelled that wrong, I apologise. So my spelling's not perfect. Asymptote, I think that's right, So sorry if it's not, I apologise. To anyone out there, asymptote, I think that's right. I think I apologise if it's not, but asymptote. I'll just delete it in case it is wrong. Asymptote. So it means that it gets closer and closer to the x and y axis but never touches it, for the reasons I've just said. Actually, I can't divide by 0, and I can't have 0 equals k over x because there's no solution. Part B, hence or otherwise solve 16 over x is less than or equal to 2. Well, if you think about it, 16 over x here is one of these graphs. Now the line y equals 2 is actually a horizontal line, looking like that. That is the line y equals 2. Think about it, the x coordinates obviously change, but the y obviously stays fixed. So if I solve it, so we've got one intersection there. So I'm going to times up by x, so we get 16 is less than or equal to 2x, and then divide through by 2, we get that 8 is less than or equal to x, therefore x is bigger than or greater than or equal to 8, so the solution is x is bigger than or equal to 8, for us to satisfy that inequality, and that makes sense, right, because obviously 16 divided by 8 makes 2, 2 can't be less than or equal to 2, that is true, because of the equal sign. If x equals, let's say, 10, 16 divided by 10 makes 1.6, which is less than or equal to 2, that is true, 16 over 11, obviously, so it follows that logic, so as long as x is bigger than or equal to 8, we found our solution. I hope that makes sense. But for these questions, guys, they're obviously pretty simple and obvious here, but always draw a sketch to avoid any possible misconceptions or missed solutions. because yeah, especially when we start looking at like some hard ones here, when you have like 16 over like x minus 5 is less than 3. Okay, there's actually yeah, there might end up being like more than one possible solution because we can have yeah like a negative. Okay, but here because obviously x is non-zero. Okay, I can just obviously times it by x. But for this one, yeah, you've got to times it by like x minus 5 here all squared, okay, which you obviously cover more in that A-level further maths. But yeah, it's always best to sketch these curves, okay, in case, yeah, like you find a hidden solution here without you realizing. But hopefully that makes sense. Okay, sorry if I actually walked, okay, hopefully that makes sense.